Welcome, boys. Today we are going to start the new chapter, that is transition and inner transition elements. Generally, you have studied in 11th science periodic table. In periodic table, there is a 118 elements. These elements are placed in different blocks. There are 4 blocks, which are that is S block, P block, D block and F block. Generally, this is the outline of periodic table. These 4 blocks, these 11 periodic tables are divided into 4 blocks. This is the outline. Here, from left side of periodic table, there is a 2 groups. Generally, this periodic table consists of 18 groups. Groups are vertical columns. Vertical columns are nothing but groups, and horizontal rows that are nothing but periods. First, this should be known. That is a vertical columns. They are nothing but groups, and there are 18 groups in periodic table. And also there are 7 horizontal lines, and that 7 horizontal line indicates that period. First of all, in 11th standard, you have studied 2 blocks, which are that is a S block elements and P block elements. The S block elements are placed at the left hand side of periodic table. There is a 2 groups. This is group first elements and this is group second elements. Group first elements, they are nothing but alkali metals, and group second elements, they are alkaline earth metals. These elements are highly electropositive. They forms monovalent ions. Then generally at the right hand side of periodic table, there is a group from 13 to 18. These elements, they are nothing but P block elements. That is from group 13 to group 18. These elements, they are placed at the right hand side of the periodic table, and also these elements are highly electronegative. These two groups, that is 2 blocks, that is S block and P block, that we have completed in 11th standard. Then in 12th standard, we have to study the next 2 blocks, which are that is nothing but D blocks and F blocks. Generally, the name of chapter, that is transition and inner transition elements, means first the transition elements that you have already completed, you have already studied. These transition elements, they are nothing but the elements in which last electron enters in d orbitals or n-1 penultimate cells. That elements are called as a transition elements. Generally are D block elements, that is nothing but D block elements. Generally these elements, why they are called as transition elements? This is the D block elements. Transition elements are nothing but D block elements, and they are called as transition because here these elements are present in between highly electropositive S block and highly electronegative P block elements. This in between these 2 elements, therefore such elements, they are called as a transition elements. That is here, this is the D block element, that is from group 3 to group 12. This is group 3 to group 12. These are D block elements. These are the D block elements. This study of this D block element you have already completed, and now then we have to study the next elements, that is called as inner transition elements. That is called as inner transition elements. In inner transition elements, they are nothing but F block elements. These are nothing but F block elements. This is the transition element we have already studied. This is group from 3 to group 12. This is nothing but D block elements. And the next one, inner transition elements. Why they are called as inner transition elements? Or what is meant by inner transition elements? or F block elements. F block elements are nothing but the elements in which the last electron is enters in n minus 2 F pre-penultimate cell. N minus 2 F pre-penultimate cells are called as F block elements. They are called as F block elements. Means the elements in which last electron is enters in n minus 2 F orbitals are known as F block elements. That means last electron enters in F orbitals, or that is nothing but pre-penultimate cells. That is pre-penultimate cells. These elements, they are placed separately at the bottom. Generally, the position of these F block elements. F block elements, the position will be present in group 3. Group 3. This is the group 3, and periods will be 6 and 7. This is the F block elements. This is present in group 3 and in period 6 and 7. These elements, they are placed at the bottom. Here, that is a lanthanum here, that is from atomic number 57 to 71, and next that will be present in group 7, that is the actinoids. That is the first element of the cell, that is actinum, and the atomic number will be 89, and last electron, that is lawrencium, having 103. These two groups, these two series of these elements, they are placed at the bottom of periodic table. Position will be group 3rd and period will be 6 and 7. Period will be 6 and 7. Then we have to study here what is the general electronic configuration. We have to study the general electronic configuration of these elements, inner transition elements. We have studied why they are called as inner transition elements, because they are placed in between highly electropositive S block and highly electronegative P block elements, and that's why they are called as inner transition elements. They are called as inner transition elements. This is about definition. Then we have to study the definition. After definition, we have to study the electronic configuration. What are the electronic configuration of these inner transition elements? That is general electronic configuration. General electronic configuration of this series will be n minus 2f 1 to 14, n minus 1 d 0 to 1, ns2. This is the general electronic configuration. N minus 12 1 to 14, n minus 1 d 0 to 1, and ns2. That is the general electronic configuration. As we know here, there are two series. This will in inner transition elements. There are two series are present. First one, that is 4f. We have seen position of this inner transition element, that is in group 3rd and period will be 6 and 7. Those elements means they are equal to n is equal to 6. Number of periods, that is 6, n is equal to 6. If we substitute the value of n is equal to 6 in this here, we get 4f 1 to 14, and that is n means 6 minus 1, that is 5, 5d 0 to 1, n means 6 is 6s2. This is the electronic configuration. 4f 1 to 14, 5d 0 to 1, 6s2. That is called as 4f series elements. That is called as 4f series elements. Means number of periods will be 6. If we substitute value of n is equal to 6 here, we get 4f 1 to 14, 5d 0 to 1, and 6s2. Means this series of elements, that is called as 4f series elements. And the 4f series elements, they are nothing but lanthanoids. They are called as lanthanoids. These lanthanoids, these 4f series elements, that is called as lanthanoids. Why they are called as lanthanoids? Because the elements present after a lanthanum having similar physical chemical properties to that of lanthanum, and that's why these elements are called as lanthanoids. Means here 4F series, they are nothing but lanthanoids. And then if you take n is equal to 7, if you take n is equal to 7, substitute value here, then we obtain here 5F 1 to 40, 5D 0 to 1, 6D 0 to 1, and 7S2. Here 7S2. It means here, if you take n is equal to 7 in this general general electronic configuration, then we obtain 5F 1 to 14, 6D 0 to 1, 7S2. It means this is called as 5F series. This is called as 5F series. These are the two series. 4F series, nothing but lanthanoids, and 5F series, that is nothing but actinoids. That is nothing but actinoids. This series is called as actinoid series. This is 4F series and this is 5F series. In that we have seen first what are the inner transition elements, definition of inner transition elements, why they are called as inner transition elements. These inner transition elements are nothing but F block elements. Why they are called as inner transition elements, and then its position. Position will be in present. It will be present in group third, and period will be 6. That is properties of F block elements. We have to study property one by one. First, properties of these F block elements. That is, generally it will be similar to that of D block elements. Second, properties of the elements, F block elements. Generally, the electrons are added to F subcell n F orbitals or F subcells in n-2 level. Electrons are added to F subcell, that is n-2 levels. Third one, the elements having atomic number 57 to 71. 57 to 71. Then next point, that is of these elements, generally they are also called as, these elements are also called as rare earth elements. That is, these elements are also called as rare earth elements. Then fourth one, these elements are fairly abundant on earth crust. Means it will be observing more concentration generally, or that will be maximum abundance will be present these elements. Then next points of these physical properties of F block elements. Generally these elements, they are metals. These elements are metals and soft. They are metals. Generally they are metals and soft and having moderate density, that is here about 7 gram per centimeter cube. These elements having these metal, they are all metals and softs and also moderate density, that will be 7 gram per centimeter cube. 7 grams per centimeter cube. They have high melting point. Next one, sixth one. Generally they have high melting point and boiling point. Melting point and boiling point will be high. Metals having high melting point, boiling point. Then next one, 7 property, that will be these elements, they are highly reactive as compared to alkali metals and alkaline earth metals. These elements are highly reactive. All these elements, they are highly reactive, similar to that of alkali and alkaline earth metals. All these elements reacts with water and forms hydroxides and also liberation of H2 gas. You could take metal. M stands for metal. It reacts with water. Metal is solid, states of water is liquid, and here it gives metal hydroxide. It gives metal hydroxide and H2 gas. we have to balance this reaction. Here we put substitute 2, here 6, here also 2, and it will be here thrice. This is the balance reaction. Here is MOH thrice. This is nothing but metal hydroxides. Generally, all these elements of a block elements, they reacts with water to form hydroxides. And also we have to also study the oxidation states. Oxidation states will be +2 and +3 and +2, +3 and +2. The common oxidation states will be +3. What is the oxidation number? We have already studied. Here this element shows +3 and +2 oxidation states. All the lanthanoids forms hydroxides. The general formula. Then lanthanoids element forms hydroxides, and their general we have to study the properties of elements. In that properties we have to study here. This is the lanthanum hydroxides. Generally they are basic in nature. Lanthanum hydroxide, general formula of lanthanum hydroxide, that is LnOH thrice, that is nothing but lanthanoid hydroxides. Generally these are ionic and basic in nature, as the atomic number, that is from lanthanum, that is 57, to lutetium, that is 71. Atomic number will be goes on increasing from lanthanum to lutetium. Here atomic and ionic radius will be goes on decreasing. Therefore, the basicity of lanthanoids will be goes on decreasing from lanthanum hydroxide to lutetium hydroxide. This is due to decrease in ionic radius. As atomic and ionic radius decreases, here the basicity of lanthanoid hydroxide will be goes on decreasing from lanthanum to lutetium. These are some properties of lanthanoids. These are the properties of block elements. And now we have to start the properties of lanthanoids. The properties of lanthanoids. In that first property of lanthanoids, generally these are metals and are all soft. These are metals and generally they are soft, and color will be white. This color will be white, silvery white. Generally color will be silvery white and having moderate densities. Color will be white and moderate densities. Density will be silvery white and moderate densities. And also these elements, generally their color and brightness of these elements will be reduced when they exposed to air. When these elements exposed to air, their color and brightness will be decreased. This is first property. Then second property, generally these elements are good conductor of heat and electricity. First one, we have seen metal, these are softs and silvery white in color and having moderate density, and also their color and brightness will be goes on decreasing when exposed to air, or reduced when they will be exposed to air. Second one, generally they shows good conductor of heat and electricity. And third one, third property, that is except promethium, all elements, they are non-radioactive. Except this promethium, all elements of this series generally they are non-radioactive. Next one, fourth properties of these elements generally are the atomic and ionic radii. We have seen usually goes on decreasing, and atomic and ionic radii goes on decreasing from lanthanum to lutetium. Here there is a size of lanthanoids will be goes on decreasing. As size will be goes on decreasing from lanthanum to lutetium, that is called as lanthanoids contraction. This is lanthanoid contraction. Why this lanthanoid contraction will be takes place? We have to study next one. But here, as atomic and atomic number increases, atomic and ionic radii will be goes on decreasing from lanthanum to lutetium, and that's why here the size will be goes on decreasing, and that is called as lanthanoid contraction. This is called as lanthanoid contraction. And one more properties that will be shows by these lanthanoids, that is a paramagnetic. What is in the paramagnetic? Paramagnetic is nothing but here there is a presence of unpaired electrons. As there is presence of unpaired electron, then only it is said to be a paramagnetic. Therefore, this contains unpaired electrons, and that's why these elements are generally they are a paramagnetic. This is about the properties of lanthanoids. These are the some properties. This you are sometimes question will be asked on that is for 2 marks. What are the properties of lanthanoids? Then we have to study the electronic configuration. We have to study next point, that is electronic configuration. Electronic configuration of lanthanoids. Electronic configuration of lanthanoids. Electronic configuration of lanthanoids generally. Configuration of these lanthanoids means for ferrics. Generally, for that purpose here we have to first draw this chart like this. Elements in that here, then symbol, atomic number, and electronic configuration that is expected and observed. Generally, how these elements are remembered. म्हणजे हे एलिमेंट जे आहे हे आपण लक्षात ठेवण्यासाठी आपण एक मीनिंगलेस वर्ड असं एक तयार केलेलं आहे की यामध्ये प्रथम कॉल, दिस इज लॅन्थनम. For that purpose we have to write La. Then next one cerium, C. Then next one praseodymium, Pra. Then neodymium, that is Nod. Then promethium, Permo. Then samarium, Samo. Then europium, U. And then gadolinium, right, Godo. Then terbium, Turbo. Then dymium. Then dysprosium, Di. Then next one, that is holmium, Ho. त्यानंतर erbium, त्यानंतर erbium नंतर thulium, Termo. Then ytterbium, Yb. आणि शेवट जो आहे lutetium, that is or Lu. म्हणजे ही जी सिरीज आपल्याला लक्षात ठेवायची असेल तर काय करायचं? ला, सी, प्र, नड, पम, सम, यु, गड, पम, सम, यु, गड, टब, डाय, हो, हर, टम. म्हणजे ला म्हणजे ला म्हणजे लॅन्थनम, सी म्हणजे सेरियम, प्र म्हणजे परसिओडायमियम, देन नड म्हणजे निओडायमियम, पम म्हणजे प्रोमिथियम, सम म्हणजे सॅमेरियम, यू म्हणजे युरोपियम, गड म्हणजे गॅडोलिनियम, टब म्हणजे टर्बियम, देन डाय म्हणजे डिस्पोर्सियम, आणि हो म्हणजे होलियम, अर म्हणजे इर्बियम, टम म्हणजे थॅलियम, थुलियम, आणि यब म्हणजे युटर्बियम, आणि शेवटी जो आपण दिला लुटेटियम, दॅट इज लू. म्हणजे इथे आपण लक्षात ठेवलं तर याप्रमाणे आपण हे एलिमेंट लक्षात ठेवतो. लासी प्रणड सम, पम सम युगड, टब डाय हो हर, टम युग लू. हे तुम्ही लक्षात ठेवा म्हणजे तुम्हाला हे एलिमेंट्स लिहिण्यासाठी सोपं पडेल. मग आता सिम्बॉल जो आहे लॅन्थनमचा La, सेरियमचा Ce, परसिओडायमिनचा Pr, निओडायमिनचा Nd, निओडायमिन having Nd, प्रोमिथियम Pm, सॅमेरियम Sm, युरोपियम Er, गॅडोलिनियम Gd, टर्बियम Tb, डिस्प्रोसियम Dy, holmium Ho, then erbium Er, thulium Th, thulium Tm, ytterbium Yd, and last one that is lutetium here. and atomic number will be here. Lanthanum 57, cerium 58, praseodymium will be 59, neodymium will be 60, promethium 61, 62, 63, 64, 65, 66, 67, 68, 69, 70 and 71. This is the atomic number. How to remember these elements? That is, we have seen this is a meaningless word. That is in Marathi. La, si, pra, nad, pama, sama, yu, gad, tab, डाय ओ अर टम यबलू म्हणजे लॅन्थॅनम सेरियम प्रोमिथियम निओडायमियम सॉरी परसोडायमियम निओडायमियम प्रोमिथियम सॅमेरियम then next one, that is europium gadolinium, then terbium, dyspremium, then holmium, erbium, thulium, ytterbium, and last one lutetium. This is the word, meaningless word that we have to understand to how to write the elements in that here. Expected electronic configuration. The electronic configuration will be right in this like this. As this is the xenon core. Why this is xenon core will be written? Because here the as we study this is xenon having atomic number 54. This atomic number 54 is inert. This is inert gas and having atomic number 54, and therefore these elements having also the atomic number nearer to that of xenon, and that's why we have to write here as a xenon. First we have to write here xenon, and then last time we have also studied the general electronic configuration of this series, that is 4F series, 4F 0 to 14, 5D 0 to 1, and 6S2. Therefore here we have to write 4F, 5D and 6S. This will be common for all elements, that is xenon core, 4F, 5D, 6S. There also xenon core, 4F, 5D, 6S. There also xenon core, 4F, 5D, 6S. There also xenon core, 4F, 5D, 6S. Here 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 also xenon core, 4F, 5D, 6S. Xenon core, 4F, 5D, 6S. Then also xenon core, 4F, 5D, 6S. Xenon core, 4F, 5D and 6S. This is the expected electronic configuration. Similarly, we can also write this as xenon core, observed electronic configuration 4F, 5D, 6S. Here also xenon core, 4F, 5D, 6S. Here also xenon core, 4F, 5D, 6S. Xenon core, 4F, 5D, 6S. Here also xenon core, 4F, 5D, 6S. Here also xenon core, 4F, 5D, 6S. Xenon core, 4F, 5D, 6S. Then also here xenon core, 4F, 5D, 6S. Here also xenon core, 4F, 5D, 6S. Xenon core, 4F, 5D. this electronic configuration, there will be somewhat a different one. One is expected and another will be observed. There is a deviation in spectral as spectral analysis will be taken. There is a deviation in electronic configuration, and that's why there is a expected and observed electronic configuration will be like this here. There, then how to write the expected electronic configuration and observed electronic configuration? As added number of xenon lanthanum is 57. Here in lanthanum, generally for a orbital will be contains 0 electrons, and then s orbital will be 2, d will be 1. Similarly, we can also fill up this. Here in s orbital 2, d1, 2, 1. Here s2, d1, 2, 1, 2, 1. Here 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 1, 2, 2, 1. You see the d orbital contains 1 electrons and s orbital contains 2 electrons here. And then here the f orbital will be filled gradually. This is 1, 2, 3, 4, 5, 6, 7, 8. Here 8. Here 9, 10, 11, 12, 13 and 14. Means here G orbitals of lanthanum will be contain 0 electrons, D will be 1 and S will be 2. Means S orbital always contains 2 electrons and D will be contains 1. Means D will be contains 1 electrons, and here F orbitals will be contains electron will be goes on increasing, gradually filling. Means here how will be this? This is xenon will be atomic number of xenon will be 54. 54 into 54 plus 2, 56 and plus 1, 57. Like this. Then observed electronic configuration. Generally here 0, 0, 1, 2. Then in this electronic configuration, observed electronic configuration, d orbitals will be contain 0 electron, 0 s 0 2 0 2 0 2 0 2. Here 1 2 0 2 0 2 0 2 0 2 0 2 0. Here there is 1 and here 2. In this observed electronic